Hi friends, in our last session, we have completed with architectural design pattern. In today's session, we are going to start with our next chapter, that is modeling of cyber physical system and cyber manufacturing system. This is Faizan Kagvi and I welcome you all to a lecture series of Industrial Internet of Things. So let's begin with our first topic, that is we need to see model based engineering of supervisory controllers for cyber physical system. So first of all, we are going to see different phases for the development, that is model based system engineering, and then after we are going to see the supervisory controller, how it's going to operate, and then what is the role of automated guided vehicles in this system. Okay, now as you can clearly see on your screen, that is the functionality and performance of a cyber physical system mainly depends on how the interaction takes place between the control system and a physical components. We know the control systems, right? Different types of control systems are available, but in case of a cyber physical system, we are going to use an adaptive control system, right? So how the interaction takes place between a control system, which is a commanding device, and a physical components, which could be the actuators, right? So based on that communication, we can define the functionality and performance of a cyber physical system. Now we are going to see the various phases. So first phase in this is called a development phase. Now the process is going to start in this development phase with a thorough analysis. Now thorough analysis of what we have to do. So we have to do a thorough analysis of a user requirement, customer demand, right? And based on that we have to describe the functionality and performance. Okay, so for example, that a customer requirement is for certain component which has to be produced, right? Let's say a gear has to be produced, right? So we have to first provide a concept specification for both the physical and a control components which are derived during a development phase. Okay, now next phase in this case will be a physical design phase. Now the what is the purpose of this phase? So this phase is going to define how the control system interacts with the sensors and actuators. Okay, now models will be prepared, and models with an accurate description of a sensors and actuators of a system are developed in this phase, that is physical design phase, remember. Okay, so the purpose of this phase is to define how sensors and actuators are going to respond, how they are going to operate, and the model of this component sensors and actuators will be prepared in this design phase. Okay, now also it is required that a control system which is adapted has to coordinate with the changes which are done in with the sensors and actuators. So we can take an example for this, that the selection of a controller hardware components such as we can say processor or a bus structures. Okay, now next phase is a implementation and testing phase. So what will be there in this phase? So in this phase the control system is moved in a real-time platform, which means we are going to check the control system in a runtime. So what is the purpose of a control system, right? It is going to give the commands to the actuators. Okay, that is controllers are provided within the control system, microprocessors are present. Okay, so that is going to store all the measurements which are provided by the sensors. Okay, calculations will be performed using a differential equations. It is going to use a mathematical model to perform all the calculations, and finally this control system is going to give a command to our actuators, okay, which are going to perform actions. Okay, so we can say that in this phase, that is implementation and testing phase, calculations should be performed within a well-defined time periods in order to determine the correct real-time functionality of this control system. Okay, so it is important to assess the impact of the duration of calculations on a communication behavior, and in case if there is any variation or if there is any difference with respect to the behavior of a simulation time, correctness analysis is performed, which can give a rise to the change in a design model of a control system. So this is how the implementation and testing phase is going to operate. So remember, development phase, physical design phase, implementation and testing phase. Okay, now let's move on. Now in this slide you can clearly see that the first two development phases will going to deliver the virtual system model, okay, which are accurate description of a system components, for example sensors, actuators, okay, the commands of the machines which are going to be a repetitive nature, Okay, so all these will be associated, and finally in a last phase the virtual system model is replaced by its real counterparts, that is physical components, and the control system is applied in a real-time environment without any modifications. Okay, now we have to see a synthesis based development of a coordination control. Now in this topic we are going to focus on a coordination control, and we are also going to see the several layers of a controller and positioning of a controller in our next slide. That is a diagram is shown in that slide. So what is the function of that? So coordination control is one of the most important aspect, because it is going to enable the, or we would say it is going to integrate or provide a connection, network connection between the manufacturing machines, equipments and the systems. Okay, the communication is only possible by this coordination control. Okay, so in this topic we are basically going to focus on supervisory controller at a coordination layer, and the interface is provided to a feedback controller at a resource layers. Okay, now the most important thing is that there is also an intermediate layer which is going to provide an interface and is positioned between a feedback controller designed based on a continuous time based model and a control logic implemented by the supervisory controller. Okay, so the system and a feedback controller from a lower layer can be abstracted as a discrete event model for a purpose of supervisory controller. Okay, at the interface, we can say that the information which is taken by the sensors, or the we would say signals which are recorded by the sensors for the various devices will be abstracted in a form of event, will be considered as an event. Okay, so that will be a command event from a supervisory controller, which are going to be translated to appropriate input signal to the actuators. Okay, so basically we know that a function of a controller is to translate the signal provided by the sensor to the actuator, that is the acting device, or the device which is going to take an action. Okay, so that can be done by a controller, but controller has to perform some processing task. Okay, in that processing task, it has to use some models. It has to run some algorithms, for example a forest algorithm, genetic algorithm. Okay, based on the calculation done, the output will be decided and that command will be provided to our actuators. Okay, so the position of a supervisory control layer in a cyber physical system is graphically depicted in a next diagram, which is going to be seen in a slide. Next slide. So over here you can clearly see it showing a positioning of a supervisory controller. At the center you can clearly see a control system is shown that includes a production control, supervisory control, resource control. Now the task of a production control is going to determine the quantity of a product which is produced as per the demand of a customer. Okay, supervisory control is going to see that whether all the tasks, whether the functioning of a machines is done properly or not, or within a specified time or not. So that is a task of a supervisory control. And resource control is going to determine whether the raw materials for the product are in a sufficient quantity in a godown or not. So all that task, and if it is not in a sufficient quantity, then purchase order will be directly provided and the required quantity can be easily made available. Okay, then after comes the electronic hardware device outside this layer. Then comes the sensors and actuators part. As we know, we have discussed about a function of what is a sensor and actuators. Then comes the embedded system layer. Okay, so this is the entire part of a supervisory controller, and then comes the physical and mechanical systems. So this supervisory controller is going to communicate with the operator as well as the other systems. Connection will be provided to the other systems by making use of a human machine interface. Okay, now let us move on and see the next. We have to see the description of an AGV system. So that is automated guided vehicles. Now what is that? So obviously we know that automated guided vehicle, as the name itself suggests, that it is automated and it is guided by computer system. Okay, so these are the driverless vehicles which are battery operated and computer controlled vehicles. Now why it is used? So it is used to transport materials within a manufacturing system. Okay, so these vehicles can be equipped with the different types of a steering and guidances. Okay, so in this case study, an AGV called a multi-mover is considered, which is equipped with one drive and one steer motor, and which is able to follow a track integrated in a floor, which means there is a track provided on a shop floor. On that specific track only that automated guided vehicle can move. Okay, remember that. Now every multi-mover is equipped with the several components that together need to take care of a given transport task. Each multi-mover will be provided with some component, each separate component, right? So all these multi-movers have to carry those components and to transport from one facility to another facility. Okay, so this multi-mover can also interact with each other, and a supervisory controller that needs to be developed has to make sure that they all safely move around, which means there is no collision between this multi-mover. They are safely moving and transporting the raw materials from one place to another place. Now components of a multi-mover. So we know that multi-mover contains two different motors, a drive motor and a steer motor. Now what is the function of that? So the drive motor drives the multi-mover forward or backward with a certain speed. Remember this. The function of a drive motor is to move a multi-mover or an automated guided vehicle either in a forward direction or in a backward direction with a certain predefined speed. Okay. Now what is the function of a steer motors? So basically steer motors enables multi-mover to take the turns. Okay. So that it can follow the track integrated on a shop floor. Okay. Now the floor codes position near the track gives an additional information about such as the presence of a switch, a junction or a dead end. So these signals are given by a floor codes which are positioned at a particular location, and that signals are conveyed by means of a cyber system. Okay, that is through internet infrastructure. Remember. Okay, so again it is an application of a cyber physical system. So to receive the commands from these floor codes which are positioned near the tracks, there must be some component provided in a multi-mover which can receive these commands, right? And again it is going to receive the commands by means of a through internet connection through Wi-Fi. Okay, so for this it is requiring a ride control component. Now ride control component will be integrated in a multi-mover, and it is going to receive the start and a stop signal to make the multi-mover start or stop riding respectively. Now, as we know that a multi-mover is a battery operated vehicle, right? So the component must be provided, the sensor must be provided, which can determine or provide a signal that when a battery level is low. Okay, so battery sensor will be provided, which is going to give an indication for that purpose, and this is necessary to stop the multi-mover safely instead of in an uncontrolled way when a battery is really empty. Okay, if a sudden battery breakdown takes place, so it will lead to a sudden stoppage of a multi-mover, right? So it is an unwanted scenario. Okay, so for that battery sensor has to be provided which can give a signal about a low battery. Let's move on. Now to prevent a collision, multi-mover obtains information about the obstacles like walls, machines or other multi-movers. So this can be done by means of a proximity sensor, that is a location sensor. So 4 proximity sensors will be provided to each multi-mover which can easily detect the surrounding, which can easily detect the obstacles like walls, machines, okay, and other multi-movers. And it is equipped with a 2 pairs of sensors at a front and a back, which means 2 pairs are there. First pair is at the front side of a proximity sensor, and second pair of a proximity sensor is on a right side. Each of these pair contains a sensor for a long range detection of up to 6 meter and a sensor for a short range detection up to 1 meter. Okay. Now there is a possibility that some of the moving objects are approaching the multi-mover comes in a direct contact with it. Okay. So in that case there must be some switch. So there it is equipped with a bumper switch. This bumper switch is going to provide a signal about a direct contact with an object, and in such cases multi-mover will stop automatically because of an unsafe situation that could arise. Okay. Now multi-mover is also equipped with the 3 LEDs to display status information for the operator. Okay. So these 3 LEDs are, one is a reset LED, second is a forward LED, and third is a backward LED. The reset LED serves as an indication of an error. Okay, and the other 2 LEDs, that is forward and backward LEDs, are used to indicate that multi-mover can be initiated in a corresponding direction. So whenever a LED is blinking or LED is on, either forward or backward, that means that a multi-mover can move in that particular direction, either forward or a backward direction. Now the multi-mover has a three buttons to operate itself. Okay, one of the button is there which is going to actuate the multi-mover in a forward direction. Second button is there which is going to actuate the multi-mover in a backward direction. And a third button is a reset type of a button which is going to we would say reset the multi-mover to its default conditions. Okay, when error occurred. Now let's move on and see the next slide. Now we need to see the interaction between the components. So you can clearly see that figure in the figure component interaction is shown. The dashed box indicates the system boundaries of a multi-mover. Okay. So this is a boundary of a multi-mover, and within this there are several components you can see. As we have discussed, there is a battery sensor indicating a low battery. LEDs are provided, three LEDs, three buttons will be provided. So we all know the functions of LEDs, we all know the functions of buttons, right? Forward button, backward button, and a reset button, right? Then we have a motor, a steer motor and a drive motor, right? Then a proximity sensors are there to avoid the obstacles, right? Then a bumper switch is there to avoid a collision with the object, right? And a ride control is provided and a wiring system is there, and this is our surrounding. So this entire dash line box indicates a multi-mover, and these are the components which are present inside a multi-mover. So it is very obvious that a wire, that is a track, and the object in the surrounding are not a part of a multi-mover, and they do not interact with these components. So what is going to happen? The wire is going to send the information to the multi-mover like start and stop signals of a ride control. The surrounding interacts with the proximity sensors and a bumper switch, because these sensors can be triggered by the objects in the vicinity of a multi-mover. Also the motor is provided, so it is going to interact with the surrounding due to the fact that a multi-mover moves. Okay. Now the ride control which is provided in a multi-mover is going to communicate with the motor to control the movements. And the proximity sensors will also going to interact with the motor. You can clearly see it is shown by the arrow. Okay, so interaction will be done with a motor, especially with a drive motor. So if a long range proximity sensor in a drive direction detects an object in a vicinity within a 6 meter, the drive motor will be slowed down. Okay, the speed will be reduced. And if a short range proximity sensor which is within a limit of 1 meter is detected in a drive direction, that is going to detect an object in a drive direction, so we can say the drive motor will stop immediately. Okay. Now the battery sensor is also provided. So the battery sensor and a bumper switch also interacts with the motor. You can clearly see by the arrow which is shown battery sensor, and a bumper switch is also interacting. Okay, so the battery sensor and bumper switch will shut down the motor if they are activated. Obviously, that is battery is low, which means that the multi-mover should not be moved. So automatically a shutdown has to take place. Similarly, a bumper switch is on, which means it has to shut down the motor. Okay, so the commands will be provided to the motor to stop the multi-mover. Now the button interacts with the motor. The error button resets the multi-mover, indicates that the errors are solved. Now also you can see that buttons are also going to interact with the motor of a multi-mover. Okay, so what does this indicate? So the error button resets the multi-mover to indicate that the error are solved. Okay, the backward and a forward button initiate the multi-mover in a corresponding direction. Now this has an influence on a drive motor. Also there is a LED provided which you can see. Now in this LED, communication is provided from a motor to the LED, which means the commands are provided by the motor to the LED, light emitting diode. Now we know there are three LEDs, right? So these LEDs are influenced by the motor and a battery sensor. You can see the arrow is coming from a battery sensor and from a motor to the LED. So when an error occurs in these components, or when a battery sensor is activated, the reset LED is activated. Okay. And what is the function of a supervisory controller in this? That it has to ensure that these components are properly interacting with each other to provide a required safety while transporting the materials from one place to another place. Okay guys, so I hope that you are clear with today's session, and in our next session we will continue with the next topic of this chapter. So till then, stay tuned and thank you all.